Hi, it's Paolo, host of the On Thin Ice podcast. In the episode you're about to hear, we talk about how artificial intelligence and other technologies can help us prevent disasters caused by climate change. Now, just a few days after we recorded this interview, the famous Sherpa village of Thame in Nepal was struck by a devastating flood from a glacial lake. It destroyed houses, hostels, and a health clinic. Scientists have long been warning us about such risks. The glaciologist Tenzing Chogyal Sherpa, who was one of our guests on this podcast, now says that he hopes the flood will serve at least as a wake-up call. As we explain in the episode, there is a lot that can already be done today to prevent these disasters from happening again in the future.
It's a little wonky through here, but that's fine. Yeah, that's great.
This clip was watched more than 10 million times on TikTok. We can see an ice skater gliding on the surface of a lake and assessing the quality of the ice. It's a problem ice skaters are facing more and more often these days. As temperatures get warmer, there is less and less ice to skate on. The ice skater in those videos is our guest today, Kottlowski. She's joined by another ice expert, Tenzing Sherpa, who is a glaciologist. So the first question I want to ask them is, should we prepare to live in a world without ice?
Yes, and we're already starting to see some of the effects around the world.
Yes, from my side as well.
Now, these are not just your personal observations. You're both using new technologies to conduct serious research out there. And that's the question we want to try to crack today. Do you think things like satellites, quantum computing, and artificial intelligence can help us avoid that worst case climate scenario?
Yes.
Yes, of course. Data is the new currency. And as much as information that we can get during the decision-making process and pre- and post-disastrous scenarios, it's very, very essential. And these advancements in satellite technology, quantum computing, artificial intelligence is extremely important in the years to come.
So there is hope.
Yes.
Yes, of course.
Welcome. This is On Thin Ice, a podcast by Iceworm Media in partnership with the Bali Peak Outlook Foundation. We bring together athletes, researchers, and innovators to look at what can actually be done right now to accelerate the transition to a more sustainable way of living. I'm your host, Paolo Bossanen, and before we start, I'd like to tell you a little more about our exceptional guests for this episode. In fact, I can't think of two guests who would be more fitting for our podcast, because they both live on thin ice, literally. Kottlowski is a professional ice skater, instructor, and social media personality based in Golden, Colorado. With her blades, she leaves marks on the surface of the ice, carving out these beautiful designs and inspiring tens of millions of viewers on social media. She's also a researcher, a historian, a creative designer, an ice safety instructor, and so many other things. We're delighted to have you on the podcast, Laura.
Thanks for having me.
This might be a silly question, but what does an ice skater do during summer?
Well, recover from the winter first. I run my winters pretty swiftly. I'm really focused on chasing as much ice as possible and making as many observations about wild ice as possible. So for summer, I'm just kind of like catching up on life, but I'm also a skating instructor. So I'm still at the rink, I'm still skating, and it's still a part of my day-to-day life. But for the most part, I go back to my other career, which is design and motion design. So I spend a lot of time doing that during the summer, as well as I'm still in the water. I'm taking my paddleboard out. I'm boating a lot. I'm still exploring lakes just in a different way.
So I feel like summer might be the perfect time to catch you for this podcast because you may have a little more downtime than usual, although it sounds like you're extremely busy. And if you wanted to skate on ice, perhaps you might be able to find some ice where your co-guest is right now, because he's joining us from Nepal. Tenzing Chogyal Sherpa is a glaciologist at a prestigious institution called ECMOD in Nepal. Tenzing has spent the last several years studying glaciers in the Himalayas. Among his coolest projects, he's been on a National Geographic expedition to place new weather stations on Mount Everest. He recently co-wrote a paper about how satellites and artificial intelligence can be used to monitor glacial lakes and help protect the local populations from catastrophic events. It's always great to see you, Tenzing. How's the monsoon season in Nepal this year?
I've got two words for that: hot and wet. In fact, it's getting too hot and too wet. I think with climate change, too is the word that you'll be hearing more and more. It's going to get too wet, too hot, too dry, too cold. So that's basically what's happening here in the monsoon right now. The monsoon is getting very, very intense, and it's being felt all around the country. We've got landslides, we've got floods, so many disasters happening at the same time. But fortunately, I think it's during this intense warmth that we get during the summer, we also have rainfall. So sometimes in a more city life, you are much more secluded from the natural environment. You sort of get some relief from the hotness. But having said that, you go outside the city area, the monsoon is bringing a lot of disasters.
Is there any ice left on the glaciers and up high in the mountains?
Yes, there's a lot of ice still left in the high mountains, especially in the Hindu Kush Himalayan region. It's diminishing and it's melting as we speak. But besides the two poles, the largest amount of ice that's still left is in the Hindu Kush Himalayan region, which is also why it's called the water towers of the world.
So have you ever thought about ice skating there in summer, Laura?
Well, I was going to ask Tenzing if he knows if it gets cold enough to have some of these lakes freezing at night, or if the lakes, remain wet and open.
I would not think that the lakes would be frozen during the summertime. Like, especially if you want to go there and skate, you would need a consistent layer or a certain layer of thickness so that you don't cave into the lake. So I think summer would not be ideal.
So it sounds like you may have to wait until the next winter, Laura. In the meantime, let's dive into our main question today. We have all heard of things like artificial intelligence and cutting-edge satellite technology. What you may not know is that scientists are increasingly using these technologies to save lives, or at least that's something I didn't know. As glaciers and ice around the world melt, this creates a range of very real dangers. It can be the ice breaking underneath the individual ice skater, or in the most tragic cases, lakes are bursting and destroying entire villages and entire communities. Just to give you a number, deaths from these events are estimated at 12,000 in a 2024 study. And this is something, Tenzing, that you included in one of your papers recently. I thought it was a pretty staggering number, because we always think about climate change as a hypothetical threat, but actually there are thousands of deaths already that can be linked directly to this kind of dynamic and new climate trends. So, Laura and Tenzing, you've both been researching different risks related to melting ice. Can you tell us more about your work, and can you help us understand better what are these effects of rising temperatures that you've seen, that you're observing right now? Laura, do you want to go first?
Sure, yeah. I think for me personally, I'm very interested in the safety side of what I do, skating on a wild ice. I've come to know that the smoother the ice, the easiest to skate on, but it tends to be the thinner ice. It tends to be the fresher ice. So I'm trying to understand ice construction from its inception to its degradation. And so what I'm seeing lately is just the erratic weather. The lakes could be freezing at night, and it could be, I'm talking in Fahrenheit here, but in the teens in Fahrenheit at night, which is normally a good sign for people to see those temperatures and be like, yeah, there's stuff freezing tonight. But then the sun, cranks up to 40 degrees or 50 degrees during the day. So they just extreme weather fluctuations, which weather the ice at a rapid rate. And back before I was studying ice construction pretty heavily, I didn't know the full life cycle of what ice looked like from its inception to its end, and more specifically the end. I knew what it was looking like from the beginning, but the signs for me weren't there, and it was a lack of communication. I think in the wild ice skating world, where for me, I've been doing this for 14 years and I didn't know to look for those signs. So now having experienced that and knowing what the full life cycle is and what the ice does on its like last leg, I'm continuing to research that more and understand that life cycle more. So for me, it's assessing and being able to read the ice as I'm skating and educate others on that.
Tenzing, you've also been monitoring lakes, but primarily the ones that have been created by melting glaciers. And what did you find out in a nutshell?
Yeah, with the changing climate and the warming temperatures, the glaciers are melting, and they're melting quite rapidly. In fact, in the recent decades, they're melting 65% faster than in the previous decades. That's based on a study from ICIMOD in 2023. Now, what this does is all of that meltwater has started to accumulate to form glacial lakes. And these glacial lakes, they've been forming all over the Hindu Kush Himalayan region. And they have the tendency to outburst because they're dammed by the moraine of the glaciers. In fact, about more than 600 glacial lake outburst floods have happened since the 1800s, and they've caused a lot of devastating damages in case of human and infrastructure damages. So these are one of the most prominent hazards in the region. And that is also why it is very essential to understand how these lakes are changing, what is being done, and how do we try to mitigate the hazards that can come from specifically these kind of risks.
So there are dozens of lakes that you sort of identified as being dangerous, right?
So basically, imagine that you have a dam that is just upstream of where you live, and then besides those dams, surrounding those dams, you've got big rocks, chunks of rocks and ice just all around it. If those rocks or those ice fall into that lake, then it'll cause a big wave, and that will actually outburst the dam, and all of that water will start to come down, and that could cause a devastating flood. So it's as simple as that. That water could outflow, come downstream, and actually wipe out all of the people and all of the infrastructure that's lying in the path. So that's exactly what's happening in the Hindu Kush Himalayan region, in Nepal, and in many places. And that has happened a lot. I'm not stating it as an example, especially like just if you look at the Everest region in 1985, there was a big glacial lake outburst flood that wiped away a newly constructed hydropower. And it took many bridges and everything, but it just gives you the scale of the damages. We recently had glacial lake outburst floods in Sikkim, and we recently had glacial lake outburst floods in Pakistan. So it's happening all over this particular region. And it's just showing that these kind of risks, these kind of dangers are getting more and more. And with the changing climate, these kind of lakes and these kind of hazards will be maybe increased by threefold. So that's what reports say.
And I think to add on to that, he's talking kind of at a major scale, but I had the fortunate opportunity to skate in Nepal and up in the Khumbu region, and even just chatting with locals when I was there, just the shrinking of the glaciers is causing the moraine walls to collapse. And so it's affecting buildings on the backside of those moraine walls. And so that's, on a smaller scale, but that's still pretty drastic for the locals that live there. And, the slow landslides that are occurring over time as ice is melting from the higher regions and coming down to the lower regions.
And it's pretty scary, of course, when you see how the valley is effectively a funnel, right? So anything that comes down is going to have a pretty devastating effect because there's nowhere else to go. It can only go to the villages, and it can only go to where the people are. So the Bali Peak Foundation, which is our partner on this podcast, just recently funded the construction of a new flood barrier in the Khumbu Valley, precisely to counter these risks. Tenzing, you know the valley very well. Do you think more of those projects are needed, or those projects can help, hedge the risks a little bit?
I think those kind of barriers are what is needed initially, because these kind of hazards will happen. So trying to minimize the amount of risk that these kind of hazards pose, putting up these kind of barriers, putting up cabin walls, that's the first step that we need to do. After that, we need to look at the problem itself. Maybe in case of Imja Lake, there has been some sort of mitigation measure where they've tried to make the outlet a little bit larger. They put concrete dams and they lowered the lake level as well. At the same time, they put similar sort of barriers, similar sort of cabin walls on the downstream, so that even if there is a flood or overflow, hopefully it tries to minimize the risk. So that's what we're doing at the end of the day, because the climate change, the cause of climate change is global. You can't do anything at a local scale, but trying to minimize these kind of risks, trying to mitigate these kind of risks at a local scale is what we can do at the moment.
And just for context for our listeners and viewers, the Imja Lake is a particularly threatening lake that has been forming just under Everest, effectively, just under Lhotse, and one that has been worrying scientists and locals. Is that right, Tenzing?
Yeah, so the Imja Lake gives a good example of research to action. The Imja Lake was a lake that was being monitored in the early 2000s because it was a lake that was growing very fast. Through satellite images, we came to know that the lake was growing at an exponential rate. So then people started to look at it. It's a very dangerous lake. It's growing quite rapidly. And there was detailed field investigations done. And then they deemed that the lake was quite dangerous. So then with enough momentum, with enough research papers, with enough sort of media momentum that was being created, that made space for funding to come to that reason. Because Nepal in itself, we have this limitation of funds, we have this limitation of manpower, and the government itself is already so stressed out that we are forced to fight between poverty and climate change. So it's a very difficult thing. And that's where these kind of research papers, these kind of media voices creates all of these funds. And that's where the Imja Lake mitigation project happened. And in one way, it sort of reduced the risk that the lake can have towards the downstream community. So at the end of the day, the downstream community is now sleeping a bit better, sleeping much better than before, that there is something has been done. There has been something done up there. So it also gives hope to the people that there is some solution there. There is some way that we can do something.
I mean, one major challenge on top of those that you just mentioned, of course, is that this work, like monitoring these lakes and studying them, is all pretty much done manually, right? Even to this day. And this is something you both know very well because you've both, for example, been using satellites and images from satellites to study lakes. But do you want to tell us a little more about how laborious that process is still to this day and why it takes so long and why it has such limited potential of actually being scaled up and like translating into more consequential action? Laura, do you want to start?
I think for me, I've been monitoring the freezing and ice out timeframes of lakes for the past 16 years and more intensely in the past maybe 5 to 7 years. I'm seeing stuff on the ground firsthand, and I've been logging information manually, like actually physically hiking there. So like some of these hikes are 12-mile hikes in to catch it when it first flash freezes. So prior to satellite data, it was just going there and trying to be there when it happens and looking at weather patterns and just making sure that it's been below freezing for this amount of days and it's been clear weather, it hasn't been cloudy weather, and I'm analyzing that kind of stuff. And then it's been frustrating going up there after a 12-mile hike and there being, water still there. But now that with the rise of satellites, I've been able to see the imagery and then see what I'm seeing on the ground there and understand, okay, now when I'm looking at this, I know what to look for in regards to what the lake edges look like when they freeze. When they're super thick, there's cracks that form and you can see the line work of the cracks. And usually that's above 6 inches or more. And so for me, it's this merriment of like handwork over the years mixed with now I'm going onto websites and also looking, kind of manually all of the time, like. And then sometimes those images aren't there because clouds get in the way of the satellite images. And so then there could be like a month goes by where you can't monitor a specific lake because it's been cloudy the whole month. Granted, different regions of the world have that type of weather. Like I'm fortunate here in Colorado where we have like 300 days of sun. So the majority of the satellite images, like I have probably more than other places in the world to grab that data from. But yeah, it's definitely very laborious. And, you know, for me, it's seeing what's out there and what the ice is doing and all of that. So I'm excited to see what Tenzing and how it affects his research.
Well, Tenzing, I see you were nodding while Laura was mentioning all those challenges. Does that sound familiar to you?
Yeah, of course. I'll start my answer with so if you're mapping one lake, so I'll talk about mapping because mapping is the first thing you do before you go for any survey. Map out the lake, where the lake is. So mapping one lake is fine. Still, I still recommend doing it manually because then you can select the images, you can select best images, you can actually delineate the lake yourself. But now increase it to 2. That's also fine. Up till 10 is also fine. But then you go to 100 and then 500, then 1000. In case of our studies, we look at whole of Hindu Kush Himalayan region. There could be more than thousands of lakes. Now imagine manually mapping all of those lakes by yourself. So that's one thing that is where AI comes in. But at the same time, we also used to use remote sensing methods of image segmentation and other processes, trying to process the image, segment the image so that you can map it. It's just a process where you try to classify images, you classify the categories within the images so that you can map better. If it's a forest, if it's a lake, if it's a glacier, something like that. All of this process is very, very laborious. And one of the many challenges, specifically in mapping lakes in the Hindu Kush Himalayan region, is the seasonality that we have, because we have a very strong monsoon here, and the impact of cloud here is quite a lot. And during that time, if you have cloud over the lake, there's nothing you can do. You either look for another image or you use other methods like their active remote sensing methods. I would not go more into that, but I'll just say that clouds are a big problem. But the other problem is something that might not come to many people's mind is shadows. We are in this region where we have one of the tallest mountains ranges in the world, so they cast big shadows. And all of the satellite images that we are using are optical satellite images, so they're just taking pictures, right? So the way the lakes are staying, some part of it may be covered by shadows, some part of it may be in the sun. So it's difficult, trying to label all of that. And that's where we try remote sensing methods. We try a lot of methods. But when you have artificial intelligence, and within that is machine learning and deep learning methods, you can actually delineate maybe 10 or maybe 100 of the lakes by yourself, then train the machines. And that's the beauty of machine learning, that you provide the data yourself and it actually learns by itself. So the thing about machine learning is that it needs manual input as well. And that is okay, because at the end of the day, the quality of data that you give to it is how it will learn.
So can you try to explain in plain and accessible terms as much as possible, because I know it can get very technical very quickly, how is artificial intelligence helping and coming into all this, and what are the benefits and also what are the limitations of it?
So artificial intelligence comes at a point when things get too difficult for us, right? Mapping 1,000 lakes, mapping 2,000 lakes for 4 decades is a difficult thing for a human being. And to analyze all of that information, to analyze all of that data, that's where artificial intelligence comes in. The beauty of it is you don't need a lot of processing from your side. You just need to just train it like this is what I want you to do. These are lakes, these are not lakes, these are glaciers, these are this. So you give some sort of data to it. Then it starts to learn by itself, and that's how you map out the lakes. And in a way, you sort of reduce the huge effort that goes into trying to create that data, create that information, and you can use your efforts elsewhere in trying to use that information for the people, for the downstream community, look on the larger picture. So that's where I think AI helps a lot, because most of what we do is trying to create this data, trying to process this data. If that part is automated, if you can actually automate it easily, then like I said, we can look at a larger picture.
So much of it is, I think, comparing satellite data too. So if you can use AA to take multiple images, like he was talking about shadows earlier, and I was laughing because I come across that problem all the time too. But you can toggle between different satellite imagery and then maybe one image doesn't have the shadows and that one does. So then it's also kind of mixing imagery together to come up with that. And that would be super helpful.
And I think, Laura, that's something that Tenzing, you wrote about in your paper, right? About comparing images using deep learning.
Yes. Keep in mind, I'm not a machine learning expert, so I'm just a co-author of the paper, but still, I can give you some insights on it. We explored that option to look at different multiple satellites, images, look at multiple machine learning algorithms, look at deep learning algorithms. So all of those have their own pros and cons. All of those have their own outputs. But at the end of the day, we were looking for that particular optimal solution where we can get good and efficient results at an ideal processing time. But having said that, there is still the issue with clouds and shadows, because it's still very difficult. Even with better machine learning algorithms, it's still difficult because it's not as consistent as you would like. And especially in many cases where you have clouds, the only option you have is mask out that region and maybe look for another day when there is no cloud. That helps if you're trying to map the lake for one time. Suppose you want to look for the changes in the lake. Maybe you want to look at a daily scale, you want to look at a weekly scale, or you want to look at an annual scale. So if you have got consistent clouds over there, you may be introducing more error when you're trying to look at that change, because maybe you're not picking up the change, you're just picking up error. So that's where all of that processing comes in. And research in itself is a process where you update yourself on and on again. You bring new methods, you explore those methods, you write a paper, it gives us some answers, you go look for other methods. And that in that way we are updating, and that's how I think science is.
And by the way, I should specify that this fascinating paper you published is part of a book called AI for Good that I would invite everyone to take a look at, because it covers a lot of different areas of science, and it's an important reflection on how these new technologies could or could not help science in some cases. And on AI, since we all care about the climate, the main kind of concern and question that I've been asking myself is, we know that AI consumes a lot of energy, and as an industry, it has a pretty terrible carbon footprint, right? So do you think in this case, the benefits outweigh the damage, or I don't know, how do you feel about that?
The benefits definitely outweigh the damage. I would not say the damage. Of course, it has its own carbon footprints, but at the same time, the benefit that we get from the AI methods that we have is specifically very useful. Like I said before, to get that information, there is so much hard work that goes into bringing data, to process all of that data, and to provide better information for good decision making. Now, if you have automated all of that, if it's all of that effort is then sort of reduced due to AI, then you can actually use all of that effort somewhere. Maybe we could use the effort somewhere to try to make the consumption of power of AI more efficiently. Maybe those efforts could be going there. So in a way, that could be a feedback loop that maybe at the moment it is it has a lot of carbon footprint, but in the long term, as we progress further and further with the help of AI itself could try to maybe make it itself more efficient, right?
Yeah, and I think this isn't something that we talked about earlier, but what I'm seeing in the West over here is the lack of water. And so being able to see what lakes are drying up and what river systems are drying up through satellite data at a global scale, I think is really, really helpful and useful. And if AI can aid in that, I think that's going to be very eye-opening for a lot of people. And I'm sure the people that study river systems and that kind of thing are already looking at that stuff. But to be able to show that through imagery to the global public, I think is going to be really important.
Okay, so we've been talking about technology, but of course, technology is just one aspect of keeping people safe. Laura, this is a big part of your work, like safety, and in your videos, you talk about best practices. So what are the things that can be done to keep people safe out there and understand what these changes, what a changing climate means for their everyday practices outdoors?
Yeah, for me, it's education. So, I became a main rescuer in an accident a couple of years ago. And what happened to the ice that day was, climate change in action. It was erratic weather patterns. It was extreme freezing and extreme thawing, um, from both the surface, so the sun radiating down on the ice, but then also the underbelly erosion from massive snowmelt over the course of the weeks leading up to the accident that I became the rescuer in. There were things that happened that day that I had never seen before, even after doing this for over 14 years. And now I'm in my 16th year, and that was the only time that I've ever broken through was that day during that rescue, helping my friends out. And so for me, I kind of got angry at the wild ice skating community for not sharing more information on a larger platform, or just like getting that information out there. Like a lot of ice safety information is, in Sweden and Norway, but it's not really shared on a global scale or at a large scale over here in the US. In the US, like wild ice skating is still fairly new. So for me, I went straight to social media to share what I know as far as ice safety, and what I've learned over the course of those 14 years. And even prior to that accident, I was sharing this information. So I knew after the accident, I was like, well, if I didn't know this stuff, and I've been doing this for 14 years, how is anyone else going to know? And so I threw myself into, the research of how ice forms and its complete life cycle till its degradation state and how rapidly that can happen. And I've been sharing videos like that on TikTok and Instagram, and starting to share more on YouTube as well. And so for me, I'm also, my background's in graphic design, and I'm a creative in that regard, and I do video editing and motion graphics. And so I know that, communications arts is a big thing that scientists can use. Partnering up with a designer or a creative to communicate complex ideas or complex information, and sharing it in an engaging way. For me, it's, I've been using TikTok as my form of getting a lot of information out there quickly, because kind of figured out this beautiful formula of inspiring and educating all in the same video, and people tend to grasp a hold of that. Like they're seeing things that they haven't seen before, but they're also understanding, um, complex ideas in a simple form, and that's engaging. And you have to make this information fun for people, like so they want to watch it. Otherwise, they might just go out on the ice and get hurt or break through or hurt themselves. And if you put a video out there that could potentially like go viral or whatever, they may have seen that before they had that experience.
In a nutshell, how do you make sure that the ice is safe before you actually hit it with your blades? Can you tell us very briefly?
Mm-hmm. Yeah, I have a few different methods. The easiest method that I use is the rock test method, or it's basically an impact test.
For testing, because it's round, it's soft.
So I take a round rock the size of two fists, and I throw it up 20 feet and out 20 feet. And yeah, I've even been doing like physics research on this and talking with physicists who have done some early calculations, and that rock is hitting the ice with like, upwards of 1,500 pounds of force. So, some people might scoff at that method because it's an easy method. You've got a round rock the size of two fists on the side of the lake. Like that's an easy method to use. And so some people think that it should be more technical than that. But, if you look at physics, like it can be as simple as that. So what I'm looking for is what the ice is doing when the rock hits. Like if it really shows, like, is the ice soft when it hits? Like, does the ice or does the rock stick to the ice, or does it bounce? If it bounces, it's nice and hard, and it's strong ice. Another method that I use is like once I get that first initial rock test over with, then maybe I will step on the ice like close to the shore with an ice screw, and then I'll drill my ice screw and I'll measure the depth of the ice that way too.
And Tenzing, the fact that the ice up there is melting quickly, and what's happening in the Kumbh Valley in general is something that is not just hypothetical for you, right? You've got skin in the game. It's hitting close to home because you were born in Namche Bazaar in the Everest Valley. And so what does the work you're doing represent for yourself, but also for the Sherpa community? Laura was talking about information, about communication. Are you hoping to make a difference in your community with your work?
I'll start with one story. I was up there in my village just a few weeks ago. I was up there for a festival celebration. So we had all of my family members, people were coming from the US, UK, everywhere. So it was a festival situation. Everyone was there. And there's this mountain just opposite of our village called Kongde. So if you see a picture of Namche Bazaar, so anyone can Google it. So it's sort of like a U shape, or you can see like a C shaped. So it's perched up in a way so that on this side is the village, and on the opposite side is this mountain. So that is the mountain that every child in Namche who grows up in Namche sees, that mountain from his birth up till his death, right? So that's the view that you see. That's one thing that's been stable in their life, despite everything that's going on in their life. But this time when we were up there in the middle of the festival celebrations, and everyone started to look outside. Everyone went to the roof. Because it was monsoon, so it was foggy, but then that day it was quite clear. So everyone was like quite concerned looking outside, what's going on? So naturally, I was also curious, and I went outside to look. And to our surprise, that mountain was black, completely black. Like there was not an inch of snow there. And the waterfalls that used to come from that mountain was also all dried up. So I wasn't the one that went there. All of my family members, all of the villagers, looking at that, they were very sad actually. They were like, what does this mean? That is very concerning. In my whole life, I've not seen something like this. Does it signify something bad? Does it mean that climate change is already here? So people already had those questions. I didn't have to go there and talk about climate change because people were inquisitive. People didn't like what they were saying. So it means that why I tell you this story is because people already know what it means. People have this connection with the environment, with the mountains, especially high up in the region. So they're very concerned. Now coming back to the science, because that happened because we had a snowless winter. There was no snow during the winters. And no snow during the winters is very devastating for the glaciers and for the people, for the water resources, for agriculture. Why? Because for glaciers, it's the primary food for the glaciers. Without snow, there is no glacier. And without enough snow that you have, a glacier is in this constant balance of how much snow it receives and how much melting it experiences. So take out the snow from the equation, then you just see melting. Bring in more warming temperatures, that's the worst case scenario for a glacier. So that's been going on. Then that meltwater starts to accumulate to form lakes, and those lakes could outburst to form glacial lake outburst floods. So it's this repetitive cycle that's been going on. And it's also like in this cycle, you bring one thing out of equation and everything starts to go round and round. And that's what's been going on, not only in the Everest region, not only in Nepal, but in the whole Hindu Kush Himalayan region. And why I talk about snow, glaciers, ice, or glacial lakes is because these are just the symptoms of the main disease. These are just the symptoms that we see right now. The climate change itself is the disease. Unless we tackle the disease itself, just tackling these symptoms will not be the solution. So at the end of the day, it is tackling climate change, looking for the solutions, climate action. So that's what we need to do. And that is also why we started this new campaign called the Save Our Snow campaign. The Save Our Snow campaign fits in nicely because Save Our Snow campaign itself is calling out to the world on what's going on. It's a climate action campaign. The hour there is trying to empower the local people, the local mountain communities, and the snow itself is signifying climate change. So that is why I think it's very important that these kind of voices are heard. Like you hear from scientists, you hear from other people, but these people that have been living in the mountains, not these people, our people, my people that we've been living in the mountains, we've been seeing through these changes, we've lived through these changes, and it's concerning for us. It's not a good sight. So trying to amplify these voices towards the general public, towards the larger media is very, very important, and especially through visual mediums like Laura has been talking about, because they are very powerful. they're very powerful to get the message through. A picture or a video is so much better than papers or written words and anything. So I think these kind of visual mediums are very, very useful. And why also it's important, I would like to say, is because the countries, especially that are being hit hardest, are the other countries that don't have the capacity to combat climate change. They don't have the financial resources or the human resources. So that is why it's important that these voices are heard and these issues are raised more and more.
It's very well said. And before we wrap up, I just wanted to ask you both, what is your next big project? And Tenzing, you were just talking about something that happened very recently. So maybe you can start. What's your next big thing going to be?
I don't know if it's a big thing. There's not much big things going around, but I will be going to one of the glaciers soon, after a month or so. So that'll be in Western Nepal, and it'll be a big expedition. But we go to that glacier every year, so that's like a routine expedition. So not something new, not something big, but something that we do every year.
What is the name of the glacier? Which one is it?
So the glacier is called Rikasamba Glacier. That's in the western part of Nepal, in the Mustang district of Nepal. So that's a glacier that we've been monitoring since 2011. So more than a decade. So we've got this consistent long-term data. So that is very important, especially when you're trying to talk about glaciers, because if you have 1 year data, 2 years data, that doesn't say much. You need this consistent long-term data. So sometimes I say that doing good science and is difficult, because getting these good quality data, consistent quality data, is very difficult, and it's sometimes boring for people. And sometimes this good science is boring.
Laura, how about you?
For me personally, I'm working on getting an online course up and running. I started Learn to Skate Outside 2 years ago after the accident that I was involved in, and just to get education out there as fast as I possibly can. And so this year I'll be making a big push to get a course online. I have workshops every fall locally, and I'm starting to travel to other rinks nationally, and I've been requested to come globally as well. So I'll be working on that. And then I'm really excited to network with more glacier scientists, such as you, Tenzing, and some other ice researchers, to be an on-the-ground citizen scientist. And I also have a little initiative that I've started running called No World Without Ice, where I'm asking people to come and fill out a form on my social media. There's a link in my Instagram bio and my TikTok bio that you can, if there's lakes and rivers that you used to skate on when you were a kid that no longer freeze anymore, I'm trying to document that and understand what's happening globally, because there's already dear friends of mine that can no longer skate on lakes outside in Austria. The Netherlands are having big issues, and they're a big skating country. And then even locally on the East Coast of the United States, there are many lakes and rivers that no longer freeze that friends and family have grown up on. So I'm trying to get a greater understanding on that to help communicate that story, because I think once people understand that it's not, decades that this is occurring over, it's like within 5 years. There's places that I've skated that are no longer skatable within the past 5 years, like ice caves that I've skated up in Banff National Park, and are no longer exist because the glaciers receded so much. So I think if people are able to see that it's happening within their lifetime at a rapid rate, that's really important. So those are a few things that I'm working on currently.
Laura, I was thinking of a solution, I was thinking of something that we can do. Like maybe you're talking about lakes, right? So maybe we could actually put thermal sensors, temperature sensors within the lake, and then put them for a year or so. And once we get the thermal regime of the lake, and then proxy it with the air temperature. And at time, once we have this long, maybe 1 or 2 years of data, we can train it with AI. So that then we can predict it much better. We can predict when we have this ice layering of the lake, and when it's most ideal to go skating. It's much easier for you for decision making. Mm-hmm. It's just a thought that came up, that could be a possible project.
Yeah.
We could delve into later
I
on.
would love that. Mm-hmm.
That's amazing. If this podcast can spark collaboration between the two of you, then it will have achieved something that I would be very, very excited about. So please do keep me posted and let me know if you end up doing something like that. Now, unfortunately, we do have to wrap up. It was fascinating to speak with both of you. Thank you for making the science and your fascinating projects accessible for all of us. Thank you for explaining and for educating, for inspiring, of course, because I find both of your profiles extremely inspiring. And I know a lot of other people online and in real life share the same sentiment with me. So I'd really like to thank you and our great production team before we close. I don't have to forget to give credit to everyone who's making this podcast possible. On Thin Ice has original music by Nadir Kasim. Our script editor and editorial advisor is Dave Vetter, and our video editor is Canyon James. And crucially, credit goes to our partners at the Bali Peak Outlook Foundation for supporting this podcast. The foundation is very serious about defending mountains around the world from the impact of climate change and excessive tourism. Check out their website to see what they're doing in the Himalayas, in the Alps, and other places. Now, I'd be curious to hear from our audience as well. What do you think about the use of artificial intelligence to help us adapt to a changing climate? Let us know your thoughts in the comments or on social media. On Thin Ice is available on Apple, Spotify, YouTube, or wherever you get your podcasts. Thanks again to our guests. See you next time. Goodbye.
Thank you very much, Paolo.
Thank you.